Hello everyone, greeting of the day. My name is Sashireka. Today in this video we are going to see what is regarding the digital multimeter. Digital multimeter is a very wide instrument. It is used in almost all the laboratories and electronics shops also it is available. The main purpose of your digital multimeter is it is used for AC measurement of AC, AC current, AC, DC voltage and as well as your resistance. And this is the content of this particular video. First we'll go for the definition. Again, digital multimeter, it is used for different types of measurements. The name as implies means digital multimeter. Digital is nothing but the output is in the digital form, and multimeter is measuring device used for multi-purpose measurement, right? And it is not only used for only measuring these types of electrical quantity, but also it can able to check the connectivity of your particular circuit, whether connection is there from one electronic component to the other, whether it is there or not. That can also be checked with your digital multimeter. And this is your typical digital multimeter. It consists of display, voltmeter section, selector, switch, ammeter section, then ohm meter section, connectivity check, diode check, probes and ports. These are the main. This is your typical digital multimeter, how it looks like. And the main parts of your digital multimeter are first your display screen. This display screen, it is very useful because whatever the measurement I'm going to get, it can be viewed in digital form, means in numbers, numericals. So digital screen, it has illuminated display, means in darkness also you can able to see a better visualization. It is having 5-digit display screen. One represent the sign value and the other for numbers, and the other is your number. So if you're going to see this diagram, in that one, 4 it will be there. One is for your sign, means whether it is a positive or it is a negative, and that 3 it will be for your number. This the manufacturer the display, it will be changed. It can also have different number also. So the next is your selection knob. The total digital multimeter is having only 3 parts. First is your digital screen, second one is your selection knob, and the third one is your ports. Now we have seen digital screen, the other is your selection port. Selection knob. So what exactly I am going to measure, whether it is a voltage or a resistance or a current, that can be selected by particular user, that is known as your selection knob. In this one you can able to select, can you see selector switch? The rotary switch is there, no? From there you can able to select which one you want, whether you want the multimeter to be used as an ohmmeter, you can able to select that. If my multimeter want to be used as an voltmeter, you can able to select that one. So according to that you can able to change. That is known as your selector knob. And the next is nothing but your port. Port it is of 2 types. One is for milliampere volt ohm, means if you're going to, means it will be in red color. Only 2 ports are available. One is red color and the other one is your black. Black is your common port. See this diagram, only 2 is available. The black color is your common port and this red is for connecting, means this is a positive. Capital A, it specifies a large current measurement. So this is your microamps and as well as milliamp. And voltage you can able to measure from here, and ohms is specified here, and a diode is there, and a connectivity also there. This is regarding your ports. And the next is your features. What are the features present in a digital multimeter? Why we are going for this digital multimeter is auto range, means it will only select the range. If you are going to keep a resistor and you don't know the value of the resistor, right? So if you're going to keep there, if it is going to be in ohms and you have connected in kilo ohms, you have connected a digital multimeter in kilo ohms, this digital multimeter, it automatically it takes a range and it will show the correct value. And next is your backlight LCD. That's what I told. It is having a illumination screen, so in darkness also you can able to visualize the value present in that screen. Next is your auto off. Auto off nothing but if the user is forgetting to off the particular digital multimeter, it will off it by its own. That is known as auto off. The next is design probes. The probes are very useful. It is very for connection. Wherever I want, I can able to connect in that 3 ports. So that is known as your probes, design probes. And next is your auto polarity. If suppose you are going to connect in a reverse manner, your polarity means positive is connected to negative and negative is connected to positive, that is displayed in your digital multimeter. And these are nothing but your features of your digital multimeter, right? And next, if you're going to see the block diagram, this is the main function. This is the internal block diagram of your digital multimeter. Fine. So the first one is resistance. If you're going to measure a resistance in a digital multimeter, what will happen? Constant current source is there and buffer is there. These both plays a major role in giving the resistance value of your resistance. If you're going to see this constant current source is very much essential to measure the resistance value. BF is nothing but your buffer amplifier. It is used to join 2 stages where there is any loading effect. If some loading effect is that, this buffer amplifier is used and that is given to your analog to digital converter, and the display it will be shown what is the perfect value. And next, if you're going to see, the second one is your AC voltage. AC voltage is nothing but if the input voltage is given to calibrated attenuator. Calibrated attenuator is nothing but it is used to decrease the value of the applied voltage so that my internal circuit will not get damaged or disturbed. Fine. So since this is an AC voltage, it is converted to it is given to a rectifier circuit and it is converted to DC, and the value are given to analog to digital converter, and the same will be displayed in your digital display. Next is your AC current. Again, whenever you are going to go for your AC, you will be using a attenuator. If you are going to calibrated attenuator is used only for your voltage, and if you are going to use for a current, you have to use a current voltage converter. It will be having a shunt resistor inside. So maximum current is converted, means it is reduced. Current voltage converter, my large current is what is that? It is minimizing the current and it is given to the rectifier circuit, and the same it is given to the analog to digital converter and it is shown in the output. Again, that's what I told. If you are going to go for volts, it is given to a calibrated attenuator. Fine. If you are going to go for current, then it is given to current voltage converter where a shunt resistor is kept. My current is reduced and then given to internal circuit. This is my block diagram where the input is taken and it is converted to digital analog to digital converter, and it is showing the output. And if you're going to see, the next is your measurement, how my measurement is made. So if I'm going to go for voltage measurement, if I want an voltage measurement, my red color probe I have to keep in the volt, and the black color I have to keep in the COM. Can you see this diagram? I have kept my COM black color, it is connected here, and red color to the where I want to take my voltage. So I'm connecting my positive to the positive of the battery and negative to the negative of the battery, so I'll be getting some voltage. If suppose my digital multimeter is showing 1, means the range you have to change. It is very high, it can't able to measure the range, so only it will show 1. So if you're going to reduce the values, it will show your values exactly. Right. And next is your resistance measurement. If you're going to see a resistor, you can able to keep the probe in that one. Again, my digital multimeter, it will take an auto range. So whichever range you want, you can able to select whether you want kilo ohms or mega ohms. Those things you can able to change as digital multimeter. Next is your diode. I can able to check my diode. That's what I told you. If my the digital multimeter is showing a 1 here, then it can't able to, means the range is it's very high. So you have to reduce the range. In this one, my diode can be connected in a resistor mode, ohm meter. I have to check my diode in a ohm meter mode. Positive of the diode is connected to the positive and negative of the diode is connected to the negative probe. So you will be getting some value. If you are not going to get the value, then it is reverse bias. If my digital multimeter is showing OL, then my diode is not working. The next, my current measurement. So this is regarding your current measurement. Fine. The connectivity should be broken and my multimeter should be inserted in the current path. So I am breaking the connectivity of my circuit and inserting my multimeter in order to work my multimeter as an ammeter, right? So this is regarding your measurement of your multimeter. So and if you're going to see different types of multimeter manufacturers will be there, so whichever you want, according to that you have to use. If you're going to go for an industry, the multimeter used there, it will be different. So you have to select a particular manufacturer where my where I am using it properly. From there I have to take. So this is my reference where I have referred all these things, and thank you so much.